Image analysis is often perceived as a very complex subject, but with the LAS image analysis module we've simplified the operation so that it's only necessary to step through the processing sequence that is ordered in a logical sequence in order to make the measurements fully automatically. You can see that in the image analysis module, the first panel here represents the number of steps that are normally taken in an image analysis measurement sequence. Let's look at these and see how we can set them up very quickly. As this is an introduction, I will skip out some of the steps as they're not necessary for this particular image. First of all, we have to select an image to measure. Well, I've got my images in the gallery and I've selected one of them that we're going to set up the processing on. The next step is to perform any image processing or cleanup on this image, and in this case it's not necessary because the image is quite clear. The next step is the threshold step that separates the objects that we want to measure from the background. In this case this is a color image, so we have a color threshold to adjust, and we can set the intensity level and the colors, and this is done interactively on the image. We notice that we want to remove some very small particles from this image, and we want to be able to separate those that are touching, so we then use the binary processing step. It might be that there are some parts of this image that we actually don't want to measure, but which we're not able to let the computer identify automatically. So we can always interact with the image and override the computer's decision. In this case, I'm going to remove from the image a region where I believe particles that we can see we don't want to measure. So all I have to do is to click on the image, and you can see I'm drawing around a group of particles, and they will be removed from the image when I click the apply button. You can also add information to the image if you want to add further objects. The frame step is used to remove the objects at the edge which are touching the edge of the frame. We don't want to measure these, so we adjust the blue frame so that we just select those objects that are within the frame. The results step, we can measure both individual features and the detail in the whole image, and we might want to simplify the operation by just simply measuring the features in this case. The next step is the measurements, and what we're doing in this step is really applying a filter that says what size of objects do we want to measure. So we want to set this so that we don't measure the small objects, because normally these are not precisely defined. We just want to measure the objects within a certain size range. In this case I set the area between a lower and an upper limit. Normally we want to provide some sort of graphical display of the results, and in this case you can see that the measurements have been separated into 10 different categories between a length or diameter of 20 to 120 microns. So the diameter is between 20 and 120. And in this case I've chosen to display those proportions as a pie chart. The colors on the screen here correspond to the slices of the pie chart. With all measurements that you make, you'll no doubt want to also record some simple information, for example to enter the project name, the preparation or the specimen type that you have been working with. These field names are not fixed. You can click on user define and you can enter your own names here as well if you want to add further data to the report. And finally, at the last step is to create a report. Reports are created in Excel. We transfer the data into various sheets of an Excel template, which can be created according to your own particular needs. The data that is exported is simply selected from this list. In practice, what is usually done is that most of the data is exported, because you can then save it, and perhaps you will be able to analyze it again later. If you hadn't saved the data, then you wouldn't be able to do that. So it makes sense to transfer it all. We also can transfer some example images to Excel. We wouldn't transfer more than 2 or 3, because these are only representative images. They're not intended to be the whole sequence. But you can transfer the threshold image, the image with labels, and the color-coded image to Excel. Having been through all those steps, as I've shown you, then you save them all away by clicking on Configuration, and in this case, this is a pollen example. So I type in the name pollen example, and now I can recall that configuration at a later date. So you can see, in order to set up the image analysis operations, I've simply moved from the top of the list of the sequences down to the bottom of the list. Now I've set up the sequence, I simply go back to the beginning of the list, select the images that I want to measure, in this case from the gallery. I'll just select these 5 images this time. I append these into the measurement sequence, and then when I click the Run Measurement button, you can see that each image is recorded in turn, and now we can see the Excel report appear. So all that was done by simply going through the step-by-step sequence and selecting the objects that I wanted to measure. So you can see that image analysis, in LES terms at least, is a very straightforward process.